you doing? Thank you so much for being here. Hello Australia, hello New Zealand, hello Antarctica, hello Southern Ocean, hello to my Southern Hemisphere, South America as well. As I greet Australia here, I will greet the other people. And how is the southern sky? Can you see Little Dipper in the sky? And is the Coriolis force flushing the water the other way? I think the southern hemisphere is a lot of fun. And also, how are the spiders in Australia? Hello, thank you so much. Welcome everybody. Madagascar and Africa, oh my gosh, you're right. Acacio, thank you so much. I forgot parts of Africa, of course, in the southern hemisphere too. I am so sorry indeed. Stephen, congrats on your book and looking forward to chapter 2. Doro, thank you so much for being here. Acacio has reminded me of Madagascar, and of course, parts of the African continent is in the southern hemisphere as well. I'm so sorry for missing that. Lovely. Looking forward to your drawings, Stephen. Okay, so basically between 1920 and the early 1960s, there was not much going on in the form of extra dimension work, which is what string theory needs as a grand unification candidate. So that's what the author here is saying, is that people were too busy with quantum mechanics and particle physics. And mind you, these topics were very successful. There was a lot of experimental success in these fields. And so, of course, they progressed, of course, they advanced. And of course, we came up with all of this more progress in those fields, okay? So anyways, speculation or work with extra dimensions just did not have too much breakthrough between 1920s and 1960s. Good night, Doro. Thank you so much. So, with physicists exploring powerful quantum methods, the implications of which gave rise to experimentally testable predictions, there was little interest in the mere possibility that the universe might be a vastly different place on length scales far too small to be probed by even the most powerful of instruments. But sooner or later, bull markets lose steam. By the late 1960s and early 1970s, the theoretical structure of the Standard Model was in place. By the late 1970s and late or early 1980s, many of its predictions had been verified experimentally, and most particle physicists concluded that it was just a matter of time before the rest were confirmed as well. Although a few important details remained unresolved, many felt that the major questions concerning the strong, the weak, and electromagnetic forces had been answered. The time was finally ripe. You are now redeemed from your sin of not mentioning Madagascar. Oh my gosh, thank you so much. Acacio, are you from Madagascar? Is that where you're from? So, the time was finally ripe to return to the grandest question of all, the enigmatic conflict between general relativity and quantum mechanics. And so, this is when people decided maybe we can go back to this original question and remember Kaluza and Klein. Remember those bold people who had injected one extra dimension and shown some progress in unifying gravitation with electromagnetism. Now, there were some things about that theory that was kind of wrong because they got the electron mass and charge wrong, but oh well, you know, things happen, and maybe they should have just been given the opportunity to update their theory and refine it further if they were given that opportunity, or research grants or money or time or energy of day. So I think this is kind of where people started to go towards. Poor Kaluza and Klein, you know? So the time was finally ripe to return to the grand